Hello students, this is the recording that goes over slides 9 through 12 of the Chemistry Unit 3 project. So slides 9 through 12 are going over talking about nonpolar covalent bonds. So you can see here the instructions on slide number 9 is to tell a story to explain to a child how your nonmetal meets its identical nonmetal and forms a nonpolar covalent bond. So remember that you should be using the nonmetal that you chose on slide number 3. Okay, so the same nonmetal that you chose on slide number 3, but remember that it's going to be meeting itself, its identical self, so you'll be using 2 of the same nonmetal. So I should type in here 2 of the same nonmetal that you chose on slide number 3. Okay, they're identical. So here are the elements that your story should have, who your 2 nonmetal characters are. Again, they're identical. So invent first names for them, and then their last names must be the type of nonmetal. Again, they're going to be identical. So for my example, I have ace bromine and pace bromine. Again, they're identical. They're both bromines. They just have different first names. Please do not copy my example here because you were not allowed to choose bromine. You weren't allowed to choose bromine on slide number 3. Okay, so obviously don't use that one because then I will know that you are plagiarizing. So what you're going to explain is a trait or a characteristic or something about them in which they are identical. Remember, it is just a children's story, so it can be something silly. So for example, they both love chocolate. You don't need to give me actual traits of your nonmetal. It's a story. It should be something that's pretend, right? So in my example, they're both identical, ace bromine, pace bromine, and they both love chocolate. Again, do not copy my example. Come up with your own thing. If you want, you can use ideas again from chapter 1. We went over some examples of traits there. Then explain how they're able to share something equally that's related to that trait. All right, so make sure the shared item is actually related to the identical trait, all right, that you chose for your story. All right, so my example would be that they are able to share something equally, specifically a chocolate bar, because they both love chocolate. That's extremely related. And how this results in friendship, now they're both happy. All right, so remind the audience that this is just like a nonpolar covalent bond. Again, you will kind of end the story here on slide number 10, explaining how a nonpolar covalent bond works. Remember that when we talk about nonpolar covalent bonds, electrons are shared equally, right? So remember that they both have equal electronegativities because they're identical atoms. So identical atoms have, I should specifically say nonmetals. Identical nonmetals have the same electronegativity, and so nobody wins the electronegativity tug of war, and so they end up just equally sharing electrons. And so we'll go ahead and we'll take a look at the Lewis dot diagram of that in a little bit closer detail in a little bit. All right, so that's our instructions. Let's go ahead and actually take a look at slide number 10 then. You don't need to write anything on here, you just need to write it on slide 10. Please make sure that your text stays on the slide. If we can't see it when you submit it, you don't get graded for anything we can't see. So if you need to, make sure you decrease the font. You can decrease the font by just highlighting everything and then coming up here and changing the font size number, okay? So let's go ahead and take a look at the framework here that you're going to go ahead and fill in. So once upon a time, there was a nonmetal named. Type their name. Again, you should give them a unique first name, and then their last name should be the actual element, right? So last name is the actual element. Okay. Who was, and then describe their characteristic or their trait. Again, it's the pretend one. So pretend for children's story. Again, you don't need to give me a real trait of the element, just pretend like, oh, they both love chocolate, just like I did in my example. There was another nonmetal named blank, so first name unique, last name should be the same element. Again, this is the same nonmetal. Okay, make sure you don't use your metal, make sure you use your nonmetal. Who also, and explain how they're alike. Again, so right here, they should both have the same characteristic. Okay, so they should have the same trait, characteristic, love of chocolate in my example. Okay? Then, because they both, and explain how they are alike, again, that's just literally the same thing, because they both love chocolate in my example. The two nonmetals, so retype their names. So in my example, I had ace bromine and pace bromine, love to share, and make sure that your object is related to your trait. Okay, so for my example was the chocolate bar. They were so good at sharing fairly that they became best friends. All right, so that is the story version of a nonpolar covalent bond. So this is just like a nonpolar covalent bond where two, go ahead and choose the correct words, different or identical, nonmetals share electrons equally or unequally. All right, so remember that these are the same element, right? So if they're the same element, that should be able to help you figure out if they are different or identical. That should be very obvious. And then whether or not they share electrons equally or unequally, if they're the same element, again, they also have the same electronegativity. So no one wins the electronegativity tug of war. So that should help you figure out if they're going to end up sharing equally or unequally. Another hint here is that it says non-polar, which means that these sides are not different. All right, go ahead and fill that out and then continue playing when you're ready. Okay, so now we need to go ahead and insert a picture of we need to insert a picture here of our Lewis dot diagram for a nonpolar covalent bond. This is going to be a little bit different than ionic bonds, so make sure that you follow these instructions very closely. So this time we have two identical atoms of the nonmetal. Again, that was from slide number 3. Do not choose your metal. You should have been talking about your nonmetal, which was either nitrogen, phosphorus, oxygen, sulfur, fluorine, or chlorine. Okay. So your nonmetal, and you're going to go ahead and take those two identical atoms and draw their Lewis dot diagrams for each step. So step 1, you need to draw each of the atoms by itself. So your two identical atoms, chlorine, fluorine, oxygen, sulfur, nitrogen, or phosphorus, and then show how their electrons get shared equally and the resulting bond. Okay, please remember, do this on a piece of paper, then take a picture and insert it into here. Okay, so I'm going to go ahead and show you the 3 possible options that you have. So let's go ahead and do this together. So if you chose a group 17 element, which is either fluorine or chlorine, all right, this is going to be what their nonpolar covalent bond looks like. All right, I'm going to go ahead and label these as, let's see here, I'm going to go ahead and label these as, what did I do last time? I labeled nonmetals as Y. All right, so I'm going to label this as Y, okay? Please do not use Y, actually use your abbreviation. So use the real abbreviation, which should either be F for fluorine or CL for chlorine. Okay, so let's go ahead and I'll draw it out though. So here is my Y. Here's my Y. Again, I have two identical nonmetals. So in your case, it would be F and F or CL, CL. Okay, this is step 1, right? So we need to go ahead and draw out their valence electrons. Remember, they're in group 17, so taking a look at that last digit, they must have 7 valence electrons. So I'm going to draw that out. All right, so 1, 2, 3, 4, then repeat 5, 6, and 7, and do the same thing with our identical atom over here. So 1, 2, 3, 4, 5, 6, and 7. You'll notice that I leave the unpaired electrons in the center. That's just to make it easier when we do step 2. So if you didn't do it this way, you can still match them up. It just won't be as easy to draw for step 2. Okay, so step 2, we need to go ahead and show how they equally share. So previously in our ionic Lewis dot diagrams, one atom completely gave an electron to the other atom. In this case, though, they're both going to actually be sharing with each other, all right? So we're going to go ahead and show how this one shares its electron with this atom, identical atom, and this one shares this electron with its identical atom. Okay, so you should have a back and forth, which was different than our ionic bonds. Ionic bonds, we only had an arrow going in one direction. This time, though, from our X to our Y, our metal to our nonmetal, this time, though, they're going to go ahead and actually share completely. Okay, now step number 3 is just to show the final bond. Remember that when we have a pair of electrons being shared, we go ahead and we just draw that as a single line. All right, so between our Y's, we ended up with one matched up pair here, and so we end up with one line. So one matched pair equals one line. Okay, one bonded line. And keep the rest of the electrons the same. So we still have these other 6 electrons on both of our atoms here. Okay. So this is what your final answer should look like, but just to check our answers, let me go ahead and I'm going to draw in blue, so you don't need to copy what's in blue. So don't copy what is in blue. And again, you should be using FF or CLCL for the actual abbreviations. Everything else will look the same though. But for this line, remember this line actually counts as 2 electrons, right? So this counts as 2 electrons. This one up here counts as 2 electrons. Here we have 2. Here we have 2. Up here we've got 2. Down here we've got 2, and down here. Okay. Now again, everybody wants a full octet in order to be happy, so we need to make sure that both of these feel like they have 8 valence electrons. Well, taking a look here, this one on the left, all right, feels like it has the 2 on top, 2 on the left, 2 on the bottom, and it believes that it has all 2 in the middle. All right, so these shared electrons, it believes that those ones are its own. So if we calculate all of these together, so 2 plus 2 plus 2 plus 2, this feels like it has 8 valence electrons, and therefore this one on the left is happy. Okay, same thing with on the right. Let's go ahead and calculate that one out. So again, it feels like it has the 2 on top, 2 on right, 2 on the bottom, as well as the 2 in the middle. All right, so again, because they're sharing those completely, the one on the right feels like it has the 2 in the center as well, and so this one also feels like 2 plus 2 plus 2 plus 2, that it has 8 valence electrons and is happy. It has a full octet. Again, don't copy what's in blue. All right, so I'm going to go ahead and just clear that out. You don't need to copy what's in blue. Just make sure that you have what is in red. All right, so pause the video, continue playing. If you had a group 17 element, if you had a group 16 or group 15, go ahead and just hold on and we'll talk about those in just a moment. All right, let's go ahead and talk about if you chose a group 16 nonmetal here. So I'm going to go ahead and label it as Y, but again, please do not use Y as your abbreviation. Use the real abbreviation. Okay, which would be O and O or S and S, right? Sulfur, sulfur. Let's go ahead and take a look here. So what we are going to do is we're going to go ahead and draw their nonpolar covalent bond. Again, step 1 is just to draw it out. So here's my first nonmetal, here's my identical nonmetal. They are in group 16, which means that they have 6 valence electrons. So let's draw that out. 1, 2, 3, 4, repeat, 5, and 6. And do the same thing with our identical nonmetal over here. 1, 2, 3, 4, 5, and 6. You'll notice that I kept the unpaired electrons in the center. If you didn't, that's okay. You can still do the matching. It looks a little bit nicer if you leave the unpaired ones in the middle. So again, your drawing should look identical, except for instead of the letter Y, so you should either have O and O or S and S, depending on which element you chose. Let's go ahead and actually match these up. I'm going to go ahead and use some different colors here. So right here, we have unpaired electrons that are being shared completely. So this is different than ionic bonds. In ionic bonds, we had our metal and our nonmetal, right? And our metal just gave the electron completely over to our nonmetal. This time, though, they're going to share with each other, so there's a back and forth. So this one shares an electron here, and this one shares an electron here. Same thing with these unpaired electrons. They also need to be shared. So this one shares an electron here, and this one shares an electron here. All right, so now we can go ahead and actually, this is step 2. So step 2 is showing the sharing of electrons. So step 3 is to finally show the final answer. So we're going to go ahead and show how they're bonded together. Now remember that when you have a pair of matched electrons, that is drawn as one single line. Okay, so in this case we have 2 pairs, so we should end up with 2 lines. So we have this blue pair that got shared, so that'll be my first line. And we have this green pair that got shared, and so that will be my second line. Okay, the rest of their electrons should stay the same, so they each had the other 4 electrons here. So 1, 2, 3, 4. Same thing over here. 1, 2, 3, 4. Okay, so that all looks good. Now I'm going to go ahead and just annotate a little bit more and just prove to you that this is a happy compound. Okay, so for now, please do not copy anything that is in pink. So do not copy anything in pink. Okay, but let's just make sure that this does actually work. All right, so remember, each bond here actually counts as 2 electrons because they're a pair of electrons. So we have 2 electrons here on top. We have 2 electrons here on the bottom, 2 electrons over here on this Y, 2 electrons here on this Y, up here, and up here. So remember that in total, each nonmetal here does want an octet, or 8 valence electrons. So let's make sure that counting this up, this works. Now, each atom believes that it has everything in the middle. So if I go ahead and take a look here, this Y believes it has the 2 on the top, the 2 on the bottom, this 2 in the center, and this 2 in the center. So 2 plus 2 plus 2 plus 2. It believes that it has 8 valence electrons, and that is a full octet, and so this Y is happy. Same thing with this Y over here. Again, it believes it has everything in the center. So it has the 2 on top, 2 over here, this 2 from the middle, and this 2 from the middle. So 2 plus 2 plus 2 plus 2. It also believes it has 8 valence electrons, a full octet, and therefore now this one is happy, and this is a stable bond. Again, don't copy anything in pink. You only need to copy what is in red, blue, and green here. You don't need to use different colors. The different colors were just to make sure that it makes sense to you. Pause the video, continue playing when you are ready. If you did a group 15 element, go ahead and just hold on for a second, and we will then talk about that one. All right, let's go ahead and talk about the group 15 example. This is if you did either nitrogen or phosphorus. I'm going to go ahead and label here that the nonmetal is going to be my Y. Again, don't actually use Y. Please use the real abbreviation. So yours should either be N and N or P and P. Okay, so let's go ahead and just draw these out. So my first step is to draw out the actual elements. Again, here's my first nonmetal. Here's my second identical nonmetal. Again, instead of Y and Y, you should have N and N or P and P, depending on which element you chose. I'm going to go ahead and draw their valence electrons based on their group number. The ending number of their group number is 5, so they should each have 5 valence electrons or outer electrons. So let's draw that out. 1, 2, 3, 4. Now I can go ahead and add that 5th one. I'm going to actually add the 5th one on the outside, just so that all the unpaired electrons are in the middle, because that'll make our drawing neater. Same thing over here. Let's go ahead and draw this one. So 1, 2, 3, 4, and repeat. Here's 5. Okay, so I did put all the unpaired electrons in the middle just because it'll be easier to show how those unpaired electrons get shared. If you didn't do that, you can still show how they're shared. It just might be a little bit messier looking. All right, let's go ahead and actually show this. So taking a look here, we've got these electrons on top that do get shared. So this one shares here, and this one shares in reverse. Again, they're identical, so they're going to actually share with each other. This is different from when we talked about our metal X and our nonmetal Y in our ionic bonds. In this instance, right, our metal just completely gave over an electron to our nonmetal, and that was it. But this time, they're actually sharing back and forth. So you should have one arrow going to this one and one arrow coming back. Let's go ahead and show the second pair right here. All right, so in the center, these ones also will pair up. And then down here at the bottom, let's go ahead and show this one. These ones will also pair up. Okay, so what we end up with is 3 pairs here. This is step 2, showing the actual pairing or sharing of these electrons. So step number 3 is to finally draw our final answer. So we have our 2 Ys, and we need to show their actual bonds. Now remember that each shared pair, so a shared pair of electrons, is drawn as one single line. So in this case, we have 1, 2, let me draw this out. 1, 2, 3 shared electrons, shared pairs, so we should end up with 3 lines. All right, so our green ones count as a line, our blue ones got shared, that counts as a line, and our red ones here got shared, so that counts as a line. So you have a triple bond, what's called a triple bond. Don't forget that you still have these 2 electrons on each side, so I'm going to go ahead and draw out those 2 electrons here as well. All right, so what we're going to go ahead and do, this is the final answer here, but let's go ahead and actually prove to ourselves that this actually works. So please do not copy anything in pink. So do not copy anything in pink. All right, again, your diagram should look identical to this, except for instead of Y's, you should have N and N or P and P if you were a group 15 element, okay? But let's go ahead and just prove to ourselves that this does actually work and that everyone is happy and stable. So over here, this nonmetal believes that it has 2 electrons over here. However, it also believes that it has all of these electrons in the middle. So 2 electrons from the top pair, 2 electrons from the middle pair, and 2 electrons from the bottom pair. And same thing with this Y over here. It believes it has all of these in the middle, as well as the 2 electrons on the side. So let's make sure that they each feel like they have a full octet, 8 valence electrons, in order to be happy and stable. So again, this one on the left believes it has everything in the middle. So 2 plus 2 plus 2 plus 2 would give us 8 valence electrons or outer electrons that it believes it has, and therefore it is happy and stable. Same thing with this nonmetal over here. It believes it also has everything in the middle, plus these 2 electrons on the side, so 2 plus 2 plus 2 plus 2. So this nonmetal, this identical nonmetal, also believes it now has 8 valence electrons from the sharing, and therefore is always also happy. Again, don't copy anything in pink. That was just to prove to you that this is a stable and happy bond between 2 identical nonmetals. Again, yours should just look like this. All right, so feel free to pause the video, continue playing when you're ready. Again, that is at this point all of the different groups that we did. We did, if you chose a group 17, fluorine, fluorine, chlorine, chlorine, group 16, which was oxygen with oxygen, sulfur with sulfur, or this one, group 15, nitrogen with nitrogen, or phosphorus with phosphorus. Continue playing when you're ready. All right, so let's go ahead and then finally just analyze our result here. So we want to know, what was your nonmetal? Again, we used the same exact nonmetal. This was from slide number 3. So again, you should have chosen oxygen, sulfur, chlorine, fluorine, nitrogen, or phosphorus. And then how many valence electrons did your nonmetal want to gain? Again, if they were both group 17, so that's fluorine, chlorine, then they want to gain just 1, right? So they have 7, want 1. If they are in group 16, based on their group number, they have 6, and they want 2 more to get to 8. And if they're in group 15, they have 5, and therefore they just want 3 more to get to 8. Okay, so again, group 17 was if you chose fluorine, chlorine, group 16 if you chose oxygen or sulfur, group 15 if you chose nitrogen or phosphorus. So based on that, how many does it want to gain? Again, depending on what group you're in, group 17 wants 1, group 16 wants 2, group 15 wants 3. Okay, so that should be easy peasy. So then how many unpaired electrons does a single atom of your nonmetal have? Again, we already talked about how many they have, right? So this is for here, right? So if you're in group 17, you have 7, group 16 you have 6, group 15 you have 5. Again, the wants go here. Sorry, I should make that more obvious. There we go. Okay. And therefore, how many bonds does your nonmetal end up making? Again, the amount that it ends up making is actually the same as the number of valence electrons it wanted. So right here, it's going to be the same exact answer right here, which we saw on the previous slide, that if it wanted 1 electron each, then they ended up making a bond, a single bond. If they each wanted 2 electrons, you made a double bond, 2 bonds. And if they each wanted 3 electrons, you ended up making a triple bond, 3 bonds. Okay, so this should be the same answer right here. And finally, the final chemical formula, this should be easy. It should just be your nonmetal abbreviation with the number 2. So don't use the letter N. Make sure you use the real abbreviation, which was either fluorine, chlorine, oxygen, sulfur, nitrogen, or phosphorus. And in our Lewis dot diagram, we saw that we ended up with only 2 of them in total. So everybody's number here should be 2. Okay, so everybody's number here should be 2. We all ended up using either 2 fluorines, 2 chlorines, 2 oxygens, 2 sulfurs, 2 nitrogens, or 2 phosphoruses to make a happy compound. That's everything for slides 9 through 12. Make sure you come to office hours if you need help on any of this. Thank you so much, and we'll see you later.